Welcome to my channel everyone. In this Python project, we are going to take a completely raw and messy CSV file and transform it into a fully cleaned and structured dataset using Python and Pandas. Before we begin, let me show you the two files we will be working with. So here is the cleaned CSV file, which is the final output we will generate step by step in this tutorial. And this is the original CSV file, which is full of missing values, duplicated rows, inconsistent formatting, spelling mistakes, and invalid data. So first I will create here a new project and I will name it as data_cleaning.py. So now we will start writing the code, and first I'm going to import the pandas library first. So I will write here import pandas as pd. It allows us to load the CSV file, clean it, fix missing values, remove duplicates, and do much more functions that we will explore in this project. And now let me show you the sample CSV file. So this is basically the path, and this is the CSV file open in the Excel. So you will notice in this CSV file some duplicate names. For example, John name, these are the two duplicates. Also the Sohaib is the duplicate as well, and also some missing values as well. And now I will show you the same sample CSV file inside of the Visual Studio Code right here. Okay. And now let's go back to the data cleaning project. We will do this complete project in 10 steps, and here I am writing the first step, that is load the CSV file. We will basically use pandas to load our dataset here. So first we need to define the file path. So I'm writing here file underscore path, and we basically need this path. So I will copy this path where our CSV file exists, and we need to type R, and then inside of the inverted commas we need to paste the path. And then we use pd.read CSV to read it into a data frame called df. Inside of these parentheses we will be using the file path. This basically converts the raw CSV into a structured table that we can analyze and clean later. And here we are done with our first step, and now let's move on to our second step, which is to display initial data for inspection. In this step, basically we examine the raw dataset to understand what we are working with. So I will print the original data here first, and I will do it by using the df.head function. That basically print the first 5 rows of the data. So I'm using here print df.head. In our previous step we have printed the file path, but we didn't write here the name of the CSV. So we have to put here slash and then write the name of the CSV, that is sample.csv. Now if I run this code, it will display first 5 rows of the CSV. That is being done by using the df.head function. And now I want to display the data info. That is basically the column names and the data type. And for that I am using here df.info function. And now if I run this code, it will display that data info. As you can see it from here, data info, right? And it displays that the total entries are 9 in total. As you can see, these are the 9 entries inside of the CSV file. Column names along with the non-null values are written over here. So 9 non-null values are there in the name, and 9 as well inside of the age. So here in this CSV, the salary is written in place of the age. So I have to modify it here, and let me add the age here as well. Age is basically written as a second column. So first one is the name and second one is basically the age. I will copy this last row and paste it over here, and it will be saved as the duplicate. Now I will save the CSV file by pressing the Ctrl S, and then I will run the program again. The age column has total 9 non-null values because nothing is missing in the age column, and same for the salary. But the department has 3 values missing. It has total 6 values available, and the last 3 are missing. That's why it's showing 6. And the joining date has total 4 non-null values, and the rest are missing. So we basically have a lot of missing and duplicated stuff in our raw CSV file. And now in order to display the statistical summary of the CSV file, we use df.describe function. So I'm writing here print, and inside of the parentheses I'm writing df.describe. And if I run the program, it will basically display the statistical summary of our CSV file. So as you can see it from here, the total entries are 9, so count is written as 9. Also, it provides us the mean value and the median value as well. So basically we have age and salary, two numeric columns, and it will display the mean value of these two columns. Also, it displays standard deviation, min, max, and a lot of other statistical data as well. So here we are done with our step 2, and now let's moving on to our step 3. In step 3, we will make sure that all the essential columns are present in the dataset. So first let me print the columns here. So I'm writing here print df.columns. And now let's run this program. And as you can see it from here, these are the columns we have in our CSV, including the data type as well. The first row of our CSV file has basically the column names. So these are printed over here. And now I am writing here the required columns, because sometimes the CSV file may be missing fields like department, joining date, employee ID, etc. So I'm writing here the required columns. So I have written here the required columns, and as you can see the employee ID is missing in the CSV file. So what I will do now, I will loop through each of these required columns by using a for loop, right? And if any of the column is missing from the data frame, I create it and set its value to none. So basically it will update the missing column automatically here. So to clearly show the difference before and after adding the required missing column, I will use basically two print statements. First, I will print df.column before the check, which shows the original column list. And then after running the section where we add any missing required column, I print df.column again. So I will write here basically two print statement, and now let's run this program. And as you can see in the output, the EMP ID column was not present before, but it appears in the list after the check. But here there is a problem. The joining date is being displayed twice, and it is because we have written the date in caps. Now let me correct and run the program again. And as you can see, this is the correct output. So EMP ID column has been added. So it will basically make sure that all the required columns have been added in the output. And now moving on to our fourth step. In this step, we will handle the missing values in our dataset. Before filling anything, I printed here df.isNull.sum. This gives us a quick summary of how many missing values each column contains. And as you can see it from here, we have EMP column missing over here. So it is being displayed as true. So all the missing values are being displayed as true. So we have EMP column missing, and the rest of these entries are missing. So these are being displayed as true. And now instead of focusing on entire CSV, let's focus on only the column number 2, which is the age. So I will make some changes here. We have all entries written here. So I will basically remove some entries from the age column. So I'm here basically removing 3 entries from the age column. Now we saw that the age column had 3 missing entries. So to fix that, I am adding here a small block of code that basically checks whether the age column exists. And for that, I am using here the if statement. If age column exists, and if it exists, we will fill the missing values with the mean age, or you can say the average value of the age. And fillna is the function that replaces missing or nan values with whatever value we specify. And we are specifying here the mean or average value. And in place is equal to true means that instead of creating a new copy of data, pandas should directly update the existing dataset. To show the effect of this step, I will basically print here missing values before filling, and it will be done by using the df.isNull.sum function, and again missing values after filling. So I will add here a print statement again after filling, right? And now I will run the program, and in the output you can clearly see the difference. So here is missing values before filling, and as you can see we had three values of the age missing and they are being displayed as true. And now let me show you after filling effect. So these are being replaced with the false, which mean that the mean or average value of the age has been added on those places. Now that we have handled the missing values in the age column, and now we are moving to the next column, which is salary. Since the logic is the same almost, I'm simply copying the age handling code and pasting it below. The change I'm making here is replacing age with salary. Now, just one more important thing here. For age, we use the mean, but for salary, we are using the median. And the reason is simple. Salary values often contain extreme outliers, like unusually high salaries. These outliers pull the mean upward and it make it unreliable. The median is much more stable for skewed data, so it give a better replacement value. Next, we move to the categorical columns that are department, joining date, and employment ID. For these columns, instead of using mean or median, we simply fill missing values with the text labels because they are categories and not numbers. So for department, I am writing unknown in Filna. And since the joining date and the employment ID need the same treatment, I am just copying this line and replacing the column name and the text value accordingly. So I will simply replace here joining date instead of department and EMP ID instead of department. Now when I run the program and check the output again using df.isNull.sum function, as you can see previously we have true values, which means that we have missing values, and now you can see all missing entries have been filled, everything show false, which means the data frame has no missing values anymore. So here we are done with the step number 4 and now moving on to the step number 5, and that is to remove the duplicate rows. For this purpose I will be using the drop duplicate function. So I am writing here df.drop duplicates and in place is equal to true. In our CSV file we basically have 3 duplicate rows, as you can see it from here as well. So before dropping them, I will basically print the total number of duplicates using the duplicated sum method. So inside of these curly brackets, I will be using df.duplicated.sum. And this will basically print the total number of duplicated rows. And then I will print it again after dropping the duplicates. So I will basically copy this line and paste it here, and I will simply change before to after. If I run this program, you can see the sample CSV file originally had 3 duplicates. And as you can see it from here, this is the first duplicate, second one, and the third one. And after running the code, the count becomes 0. And here we are done with our step number 5, and next is step number 6, where we focus on cleaning text columns and fixing date formats. So I will write that here as comment. And first I will trim any extra spaces from the name column because sometimes name have leading or trailing spaces. So I will write here df name is equal to df name, and then I will use .str.strip function in order to get rid of the extra spaces. And after that I will make all department names lowercase so they can stay consistent throughout the dataset. And for that I'm writing here df department is equal to df department dot str dot strip, and the function that will basically convert it to lowercase is dot str dot lower. Now all the department name will be converted to the lowercase, and then I will convert the joining date column into proper date format. In order to convert it, I will be using pd.to_datetime, and here I will use errors is equal to COERCE. This simply means that if any value cannot be converted into a valid date, it will automatically be turned into a missing value instead of causing an error. Before and after the cleaning, I will print the data frame so that you can see the difference clearly. For that I am writing here print statement after cleaning strings and data frame. And then I will write here a print statement df.head. And then I will copy these two lines and paste it here, and I will simply change after to before. And now I will run the code in order to see the difference. And as you can see it from here, previously we had department names in uppercase, and now all of these are converted into lowercase. And joining dates are previously non-standard, and now they are in a proper format. So these are basically the updates that we have made in our step number 6. Now we move to step number 7, which is filtering and sorting the data. And here I will keep only realistic age values. That means ages between 18 and 60. Any row outside this range gets removed. So I will write here age greater than equal 18 and df age less than equal 60. So that is basically a filter, or you can say age filter. I also apply another filter where salary must be greater than 0, because a negative salary does not make any sense. So I'm writing here df salary greater than 0. After filtering, I sort the data by name column, so everything appears in alphabetical order. So I will use df.sort underscore values, and I will sort it by name. Again, I print the data frame after filtering and sorting. So I will use this print statement for that purpose after filtering and sorting. And then I will use another print statement in order to show the data frame. If I run the code, and as you can see here we have the data for the ages. And if I make here a little change, age is equal to 61, then this row will automatically will get removed due to the age filter. As you can see it from here, age 61 has been removed after filtering. So here we are done with our step number 7, and now moving on to the step number 8. In this step, we will handle the outliers in our numeric columns. So if you look at the sample CSV, you will notice that some salary values are extremely high and clearly unrealistic. So here we want to fix those by defining an acceptable range for each numeric column. And since our numeric columns are age and salary, I store them in a list, and then I will use a loop to process each one. Inside the loop, I calculate Q1 and Q3. And just to explain, Q1 is the 25th percentile and Q3 is the 75th percentile. These help us understand how the data is basically spread. The difference between Q3 and Q1 is called IQR, the interquartile range, and this shows the middle 50% of the data. So using the IQR, I will calculate the lower limit as Q1 minus 1.5 times IQR, and similarly I will be calculating the upper limit as Q3 plus 1.5 times IQR. Anything outside this range is considered an outlier. And I will print these lower and upper limits for age and salary so the user can clearly see the allowed range. So I will write here these print statement in order to display the lower and upper limit values for age and salary. So as you can see, these are f strings, so I will be calling the lower limit in the curly bracket, and very similarly I will print the value of the upper limit inside of these curly bracket. And then finally I will clip the values, and for that I will be using the clip function. After running the program, you can see the calculated outlier limits right in the output. You are able to see the outlier ranges for age and salary both, and it displays the lower limit for age, upper limit for age, lower limit for salary, and upper limit for the salary as well. And this completes the step number 8, which basically is about handling the outlier values. And now moving to our step number 9, which is basically fixing data types for a clean output. In this step, what we will do basically is to fix the data types to make sure that the final CSV is clean and consistent, right? So first what I will do, I will print all the current data types using the df.d types, and I will print it before doing any data conversion. And here you can see that the name, department and EMP are objects, age and salary are float 64, and joining date is also an object. We want each column to be in correct format, and currently it's not. As we know that age and salary are in float 64 format and it should be in int 64 format. So first I will convert the age to numeric, and for that I am using pd2 underscore numeric, right? After converting it to numeric, I will make sure that the any missing value should be filled with the mean value. And for that I will be using the fillna, and any of the missing values should be replaced with the mean value. So I will use here dot mean, and in place is equal to true. And after that I will round it and then convert it into an integer type. Both of these things can be done in the same line, so I will be using dot round to convert it in round. So I'm writing here dot round, and then in order to convert it in int 64 I will be typing here as type int 64. I will copy these print statements and I will just make a change here after. At running the program, you can see before we have the data type of age as float, and now it is int 64. And now we need to do the same thing for the salary because currently it is in float value. So what I will do, I will copy the age section and I will paste it over here, and I will just simply replace the age with salary. After making these changes, I will basically run it again in order to validate. And as you can see, the salary is now in the integer 64 format. Next, I will make sure that the joining date column is in correct date format using the same data conversion method we used earlier. This ensures all dates are valid and consistent. This is the same thing that we have done earlier, but just to make sure that the date is in correct format at this step as well, I have repeated this step here again. And finally, I will convert the object type columns into string format, and those are name, department and employment ID. So first I will be converting the name from object to string type. For that I am using as type, and I will be using here string so that the object can be converted into string. I will copy the same line and paste it over here again, and instead of name I will be using the department and EMP ID. Just minor changes, and now if I run the program, you will be able to see all of these data types have been changed and now they are in correct format. The EMP, department, they are in the string format, name is also in the string format, age and salary are both in the integer format that exactly we want. And now moving on to the final step, that is the step number 10, and that is saving the clean data to a new CSV file. Here I will create a variable for the clean file path and give it a name like clean underscore output.csv, and I will give it the same file path that I have provided earlier and give it a name clean underscore output. And then I save the clean data frame using to underscore csv function with the index is equal to false. This simply means we don't want the index column to appear in the final CSV file. After that, I print a message saying the clean data has been saved successfully. And if I run this program, in the file directory you will be able to see a new file created, cleaned underscore output. If I open it, and here is our cleaned output, and previously we have this raw sample CSV file. This cleaned output file also have some missing values, so let me make some changes here. So first I will remove in place is equal to true from here in our step number 4 from the categorical columns. I have changed the undown from some other stuff, but let's change to not assigned again. And in the step 6, while converting the joining date to proper date format, I will make sure that if anything is missing, then it should be filled with some unknown, or you can say not provided value. And if I run this program, and now let's open the clean CSV output file, you will be able to see all the values are now properly filled. So that's it for this tutorial, guys. In this project we have learned how to load raw CSV file, how to inspect it, add missing columns, handle missing values, remove duplicates, clean text, convert dates, filter and sort records, fix outliers, correct data types, and finally export everything into a clean and professional CSV file. And this was a complete project, guys. If you find this video helpful, then please hit the like button and subscribe to my channel. Thanks for watching.